Hello everybody, my name is Mathijs Harmsen and I would like to tell you something about the diagnostics exercise we have been performing with integrated assessment models lately. And we are doing this to classify models based on their behavior and also try to understand the reasons for differences between models. And this is done by assessing model responses based on indicators in simple stylized scenarios, basically feeding the models a prescribed carbon text and then seeing what kind of behavior they show. And this is done with all main process-based IAMs and based on the work in the research projects MPAIR, Advance, and Navigate. And you should see this as analogous to what is done with climate models, where also a set of standard indicators exist that classify behavior, such as the climate sensitivity or transient climate response. And these are in principle arbitrary numbers, but they show which models are cool or hot or fast or slow, and how sensitive they are to carbon emissions. And here we also propose a set of indicators that were originally developed by Elmar Kriegler et al., but here we add a few and also propose a few changes to be used as a standardized set also in future studies. And we define those as the effects that we see in 30 years from now, in this case 2050, and also for standardized carbon tax. First one is the relative abatement index, where we basically look at the relative abatement in CO2 compared to the baseline, the emission reduction type, are emissions reductions realized via supply or the demand side options. Transformation index shows how much the energy system overall changes. Fossil fuel reduction, there is basically only the reduction in fossil fuels compared to 2020. Inertia timescale is a measure of how fast the model can react. So the conversion speed of a price shock and a default scenario. And the last one says something about the cost of mitigation. And the useful part of this is that it can not only be used to classify models, but also track progress, because we look at different model versions, as you will see in the next slide. And this is just one example of the relative abatement index. So the relative emission reduction after 30 years of introduction of a tax in 2050. Here you see the tax, and then obviously the reduction in that same year. And if we look at all the models, here you also see the models listed that we included. On the x-axis, you see how much reduction is realized compared to the baseline. So more to the right is more reduction, more to the left is less reduction. The stars represent the latest model versions, so we can also compare versions, which was in fact actually very useful because we could then also understand where changes came from. And we also classified the types of models, as you can see all the way to the right. So general equilibrium or partial equilibrium, and then intertemporal optimization or recursive dynamic solutions. So there we try to find out if also that matters. If a model type also defines how much reduction is realized in this case. So this is very useful information also to be able to understand studies that have been done with these models. And you can look the paper up and also look at the other indicators via this DOI. And if you have any questions, please let me know or contact me in any way. Thank you.